So to conclude the class from Monday, we spoke about property pair constraints, about how to validate. We're talking generally about how to validate RDF graphs using SHACL, using shapes graphs. And we saw this example where we said that the award, the year of an award must be less than the year of the movie. Okay, maybe less than or equals would be a better example for in practice, and also that the awards that come before or after a particular award, the years of those awards must be different from the current award year using disjoint width. So we have one other type of constraint, which allows us to basically say that only the properties defined in the shape should be defined on the nodes targeted by that shape, which means somehow that in this case, we have an Academy Award node shape. So we have a shape for validating Academy Awards, and we target instances of Academy Award. And then we define that win movie must be of type IRI. That year must be a data type of type G year. And then we add this closed true. And what this says basically is that any property not mentioned here should not appear on nodes targeted by the shape. So effectively, it means that Academy Awards can only have win movie as an outgoing property or year as an outgoing property, but as well that we can add a list of exceptions. So we can say that it can also have a value for previous and a value for RDF type. It can have both of these as well as outgoing properties. So if we look at this, our example again, we see that this is okay. We don't have any forbidden outgoing properties. We just have a year and type. So this is okay. This node here has type, previous year and win movie, which are the 4 we allow. It fails. Why does it fail? Ignored properties previous, RDF type, year. Because the year is not G year, it's an integer. So we have the wrong data type here. In this case, we have previous and we have 2 types, which should be okay. In this case, we have previous RDF type win movie year. So this looks okay. And finally, we have this last node here, which has winner, previous and RDF type. And we see that winner is not a property. We have our other win movie. So this looks like it's going to fail because it uses a property that's not mentioned by the shape or ignored here in this list. So this essentially restricts the definition or the description of a node to use certain properties. Okay, so another type of constraint we can specify is to directly write a SPARQL query that will give us all of the constraint violations. So the things that break the constraint. So if we want to, in our SHACL, in our shape described in SHACL, we can use this SPARQL constraint. So we just say, okay, we have a shape for Academy Best Picture, where we're targeting the class Academy Best Picture. So we're targeting all of the instances of Academy Best Picture. And then we write a SPARQL query that effectively, that given a particular targeted node, for example, one of these 5 here, it will query for things that will represent a constraint violation. So we say that given the current, the node that we're targeting, we're going to get its year, and then we're going to get the year of the movie that won that award. And then we're going to convert the year to a number and add 1. And we're going to make sure that essentially it's either a year ahead, that is the year of the movie, or it's the same year. So it's within 1 year, the year of the movie and the year of the award. So, okay, so well, this is not and not, so it's, but this expresses that it's within 1 year. So the results for this query here, if we were to run them, would indicate constraint violations. So effectively, we're looking for whatever is returned by this are problematic. They're nodes where the year and of the award and the movie are more than one apart. So in this case, this is okay. In this case, it's okay because we see that this one is okay because there's no win movie, so it's trivially satisfied. It's not going to be returned as a result here. We see this is okay because it's the same year. In this case, we have no win movie, so this is okay. In this case, we have a win movie, but the win movie is 1 year ahead, so this is not okay. So what we want is that the movie is of the same year or the year before as the award. And in this case, it's okay because we have a win movie, but we don't have a year directly on the award. So essentially the idea here is that we can write SPARQL queries as well and use SPARQL queries to find or to apply validation and find violations of constraints. So that's SHACL. That's pretty much all the features. There are some, other additional features, but these are the main features of SHACL, which is a standard for validating RDF graphs. There is a second language called the shape expressions language, which is very similar, which has also been published, but not quite standardized. So it's more of a different recommendation for validating RDF graphs. And essentially it emerged from the same discussions, but there was some debate about whether or not shapes should be written in RDF, or if it would make more sense and somehow maybe be more intuitive to describe a language that is not based on RDF. And that way it could be maybe a bit more intuitive or a bit more freedom in the syntax to define more things. So this is just an example of the syntax here, where we have an award shape where the year should be G year, the name should be one or more language string, and the judge, we can have 0 or more nodes that satisfy the person shape defined here. So this is essentially how we describe the same shape as we have here, shape graph that we saw in the previous class. How we would describe it rather in SHEX. So we can achieve very similar things with both SHEX and SHACL. So SHEX is also used by Wikidata, for example. So Wikidata uses shapes in order to check or validate the description and the completeness of certain types of entities, for example, actors. Okay, I won't go into too much detail on SHEX because it's quite similar to SHACL. Mainly there are syntactic issues and a couple of other minor differences, but it's the same idea. So shapes provide us then this optional way to validate schema, or to describe validating schema, to validate RDF graphs. So it allows us to add some structure to data. So with this, we kind of have the best of both worlds in that, compared with, for example, relational databases, we don't have to impose a structure or schema from the start, which means we don't have to define what are our tables, what are the columns of the tables, what are the types of the columns, and so forth. We can just add nodes and start adding edges between those nodes in a more flexible way. However, we can impose a schema anytime we want using shapes. And with shapes, we can sort of define what kinds of properties we want, how many properties we want for different types of nodes describing different types of entities. So we can later come back and impose a structure on the data using shapes. So we have this sort of best of both worlds with this optional schema. I'm not sure if there's any questions or doubts.
No.
No? Okay, so we can go to Discord. So I'm going to stop share.